This video will continue our discussion of triple integration by finding a triple integral that represents the volume of a solid. Okay, it's bounded by this. This is our surface. This is the xy plane. And then x equals 0 is the y-axis. And then let's take this. Let's take a few things. I already drew my graph, so I wouldn't have to spend so much time because I get a little perfection. I become a perfectionist about it. So let me explain where all these graphs came from. I start with my xy plane. I'm trying to project this down onto the xy plane. So to do that, I just have to let z equal 0, right? Z being how high or below the x-axis, xy plane we are, so if I just let z equal 0, that is the xy plane. This is y squared equals 4, which tells me that y is plus or minus 2. So we only have to worry about plus 2. So if you notice in pink right there, I drew a y equals 2 line right there. That is my y equals 2. I didn't have to do negative 2 because it says it is caught. The next line is going to tell me that. So this one, the purple line here, comes from here. If I solve for y, right, it's y equals 1/2 x. Right? We also, I don't want to forget that we can use the x1 too. All right, so that's where I got my purple line, is y equals 1/2 x. That's just mx plus b. So I graphed it. Slope of 1/2, and then we can see where the area is caught between. Remember, this is my y-axis. This is the flat plane that we're on right now. This thing's going to be above what we're on, and then this is the line that we created in purple there. The yellow region, the shaded region there, is the surface is going to live above that or below it, depending on what we're trying to find, and we're going to find the volume. Now, I'm going to show you a key word here, setup. We're going to do a whole lot of this. The reason being, like, if I work out every single triple integral, the videos start getting very, very long. And I know how that goes. I know if I were even my age now trying to watch videos for class, if you gave me a video that's 40 minutes, I don't know if I would watch it. And I think that time limit's getting even shorter now. I mean, I think when I open a website or if I'm scrolling on social media and I see 5 minutes, I'm like, no. So let's keep the video short. I will give you answers to the integral. Let's go ahead and set up the integral, and then we'll talk about that. So when I'm doing this, I actually like to set up my bounds like this. And this is going to help us because we're going to get to other coordinate systems as well. Okay, I can see that z is above or stuck between this surface and the xy plane, which is 0. Now, y and x, we get to decide which way we want to do this. We could do it a couple of ways. I'm just going to do it with the way I have it set up. If I look and see where y goes from, it goes from the purple line up to the pink line the whole time in that region. So that tells me that y is between the line, so that's 1/2 x, and then the other line, which is just 2. Now, x, we have to figure out where they intersect. So we're going to have to set these two things equal. So 1/2 x equals 2. Well, that's just x equals 4. So I know this is, and we just took these two things and set them equal to each other right there. And that told me the intersection point right there. So I know x starts at 0 and goes up to 4. So let's set up our integral. Anytime, and I'm going to say this quite a bit, anytime I want to find volume, I let my integrand be 1. If I'm going to use x, y, and z. Let me show you what I mean. Right, x is between 0 and 4. Y is between 1/2 x and 2. And then the last one, z, is between 0 and 4 minus y squared. Anytime I just want to find volume, I need to just put a 1 there. What's really happening there is it could be treated like a density function. If I put a function where that 1 is, that's actually measuring the density. Oops, I don't know what that was. Measuring the density at each point. We're not going to, I think we worry about that in an example or so, maybe the motivation, I can't remember. So now I just set up my bounds, dz, dy, dx. This integral is totally doable. Just like the first couple examples. I'm not going to use video time to do it because it's pretty straightforward. I would encourage you, if you got the time, to go through and try to get 8 out of that. Depending on the semester you take me in, depending on time we have, some of these problems on, usually in a test, I'll have you do a couple triple integrals, and then I have you just set up a lot. to save some time, and then I only need to see you work out a triple integral once or twice. So, there's another integral problem. Again, the worst part after a while will just be set up. So that's why I'm having you just set up quite a bit.